This is our Fed project, Scuttle, an animatronic crab that functions as a walking table. Scuttle uses 3D printed legs, foam board tabletop, and Vex robotics parts, in particular a Vex PIC microcontroller, transmitter, motors, and effective crankshafts.
The history of animatronics is kind of amazing when you consider it all, starting with just clocks placed in city squares and other places of importance where a lot of people would, gather. And then these clocks, they would have like mechanisms which were like animatronics that popped out and did like dances or performances or whatever. And then eventually you go from that to having things like the first human animatronic based on Abraham Lincoln, which was made by Disney. And Disney goes on to become one of the most important animatronics industries ever. And now, even today, we're refining them to have facial expressions, human movement, and so much more.
The inspiration for our project was Theo Jansen's wind-powered strand beast and a table that James had previously built. The table has practical applications that could be brought to the real world and made our project unique.
After finalizing the idea for our project, there were a few restrictions that we had to consider. These include that the animatronic figure must move on its own, the final product must fit within a half-meter cube, the figure must have a creative intent associated with it, the figure should be battery-powered, the figures will be based on creativity, function, and intent, and, lastly, that the budget is $40.
The inspiration for our leg design came from Theo Jansen's strand beasts. We used a computer simulation to get the dimensions for the leg parts, which were then 3D modeled and printed to fit those dimensions.
The legs of our project were 3D printed from designs that we drew. We used the Lulzbot Mini 3D printer and PLA filament. It took a couple tries to figure out how the printing software worked, but after that the printing and putting together went smoothly.
When we were considering designs for the tabletop of the table, we kind of were thinking about the design of the legs and how they were kind of crab-shaped or spider-like. But the spider design would have been kind of creepy, so we went with the crab, and it really doubled as a really cool design that was complete with coasters and just was a good tabletop in general.
We encountered a variety of issues while building Scuttle. One of the major issues that we did encounter is that the Vex microcontroller that we used is nearly 10 years old, so finding software to code it was difficult and required a specific type of cable which we didn't have access to. That severely limited our ability to code the microcontroller and control the motors. Another significant issue that we encountered was that when the weight of the frame of Scuttle was placed on the legs would often buckle and lock into place. And in order to combat this issue, we redesigned the point of contact of the ground of the feet to discourage the locking, but it still happened sometimes, so we added wheels to the ends of the crab to hold the weight of the load but still allow for the legs to propel Scuttle.
For the tabletop, we had to choose a material that wouldn't add a lot of weight but was still sturdy. We considered plexiglass, foam board, and cardboard. We decided to go with foam board because it was lighter and cheaper than plexiglass and stronger than cardboard. The eyes that doubled as coasters for our table were also made from foam board. The tabletop had to fit within the project dimensions but also cover all of the mechanics underneath.
We all felt pretty confident going into design day, and our project ended up faring pretty well. Despite a couple issues we encountered that involved using a hairband to fix one of the legs, our project ended up winning for the animatronics section.
I'd say you need to start pretty early.
Start early? Start very early. start early.
You're gonna want to be unique.
My advice for next year's freshmen is to meet often because you don't know it until the end, but the end is already on you. So you gotta know what everyone's doing.
One important thing to consider is like stress testing your project, because we designed the legs in an online program, but we didn't anticipate that it wouldn't be able to hold up the weight of the rest of our animatronic, so we had to do some last-minute redesigning to fix that issue.
To next year's freshmen, I would say that while the Fed project is a great opportunity to learn new things about fields you might be interested in, it's also important to stick to the strengths of your team to an extent, because that's going to make it a lot easier for your team to follow through on whatever idea